Hello and welcome to this presentation. My name is Hadi from University of Klagenfurt. I will be presenting our paper towards viewer adaptive streaming of holographic content. There are many challenges in digital holographic video display systems. The first challenge is related to displays. They are still very premature and heterogeneous in design, and there is no established standard that specifies how to supply holographic data to the display. Recording holograms at high resolution is very difficult and it needs an expertise to build and operate the setup. Computer-generated holograms are more calculation-intensive than classical image rendering. As holograms are completely different from natural photos and contain more sparse data, there is a need for a new transform for encoding and compression of holograms. Quality evaluation of holograms needs a new model for perceptual visual quality assessment. If you are more interested for challenges in digital holographic video display systems, please have a look at the following paper. Workflow for end-to-end hologram delivery is shown here. Once a hologram is acquired, is encoded and generated bitstream is transmitted. Then, based on the user's selected viewport, this generated bitstream is decoded, rendered, and displayed. Our focus in this work will be on transmission part, which means we will try to reduce the bandwidth requirement for delivery of the holograms, and in addition, we will try to satisfy user experience needs. Some information about the use dataset is shown here. It contains diffuse holograms generated from three-dimensional point clouds. Each hologram is stored as a matrix of complex numbers, and because there is no encoder for complex numbers, holograms are divided into two parts, real and imaginary. Then both of them are encoded using an ordinary image or video encoder. Each hologram contains information of all views. And in order to render each requested view, the corresponding area of that view should be extracted from the original hologram. Here we can see corner views of the one original hologram and their corresponding area in the original hologram. Because each part of original hologram is used to generate one view, different streaming strategies can be defined. In this paper, we define 4 streaming strategies: monolithic streaming, single view streaming, adaptive view streaming, and non-real-time streaming. In the monolithic streaming, the entire hologram is encoded and transmitted because instead of encoding and transmitting only the corresponding part of the selected viewport, all the hologram is encoded and transmitted. It will lead to a bandwidth wastage and increased encoding and decoding time complexity. On the other hand, because the user has access to all viewports, the monolithic streaming will be the best user interactivity solution. As you can see here, the entire hologram is encoded at different bit rates and is stored on a HTTP server. Then, based on network condition, the appropriate segment is selected and transmitted to the client side. And then, based on the user's selected viewport, this encoded hologram is decoded and displayed for the user. In the single view streaming, only the corresponding part of the requested view is extracted, encoded, and transmitted. Because only corresponding part is transmitted instead of whole the hologram, this solution will lead to highest possible bandwidth reduction and the minimum encoding and decoding time complexities. But it should be noted that this solution is impractical in user interactive hologram display systems. As you can see here, only the corresponding part of the requested viewport is extracted, encoded, and transmitted. So for single view streaming, corresponding part of all the viewports are encoded and stored on a HTTP server. Then based on network condition and selected viewport, appropriate segment is selected and sent to the client and decoded and displayed for the user. In order to solve the user interactivity problem in single view streaming, we select the area of the original hologram that not only contains the requested viewport, but also it contains its neighboring viewports. As an example, if this block is corresponding area of this requested viewport, then we extend it from each side to contain neighboring viewports. So if D is equal to 256, then this portion of the original hologram will contain 512 by 512 views. The only difference here with single view streaming is that each segment contains extension of the corresponding area. In this way, the user experience will increase because the user not only has access to selected viewport, but also it has access to its neighboring views at the same time, and it will avoid freezing when user changes the viewport. In non-real-time streaming, for each view, a portion of the original hologram should be extracted, encoded, and stored. Considering 8,192 by 8,192 single views, it will increase the amount of required storage space in HTTP server. In order to solve this problem, we divide each original hologram into 16 parts. And based on the requested viewport, we only select the overlapping parts and transmit only these parts. As you can see here, this blue part will be selected and transmitted to the client side. And here we will need only to store this 16 small part in HTTP server. But it should be considered that this blue part still requires huge amount of bandwidth, and in order to reduce required bandwidth, we again divide the original hologram into smaller parts. So in this way, we can see that the orange part, which is overlapping smaller parts of the original hologram with the requested viewport, will need lower bandwidth than the blue part of the previous proposed method. In this way, not only the required storage space will decrease, but also the required bandwidth will be decreased. Various streaming strategies are compared in terms of bandwidth consumption and bandwidth saving against monolithic streaming. And because in non-real-time streaming, the entire hologram is divided into smaller parts and each part is encoded independently, the overall bitrate increases. This BD rate increase for non-real-time streaming against monolithic streaming is summarized in this table. And finally, encoding time complexity for various streaming strategies is shown in this figure. In conclusion, monolithic streaming requires the highest bandwidth and encoding-decoding time complexity. Single-view streaming doesn't provide user interactivity. Adaptive view streaming is very efficient in terms of bandwidth consumption, and it provides user interactivity. And the last scenario is used in order to reduce storage space in non-real-time streaming scenarios. Thank you very much for your attention.